Welcome to Lesson 04. This is where CrowdSec stops being magic and starts being mechanics. Stage 02 is all about detection, and over the next 3 lessons we'll trace a single log line all the way from disk to a stored decision in the LAPI. Today we tackle the 2 hardest concepts in the entire course: Grok patterns, the regex-like language parsers used to extract fields, and the Leaky bucket algorithm, the math behind every scenario. If you're coming from fail to ban, think of parsers as your new fail rejects and scenarios as find time, max retry, and ban time rolled into one. Same idea, much more powerful. By the end, you'll have written 2 YAML files, a parser under s01 parse, and a brute force scenario that fires on 5 failed logins in 60 seconds. So before we dive into syntax, let's situate ourselves on the map. CrowdSec's detection pipeline has 4 stages. Acquisition reads raw lines from files, journal.ctl, Docker, Kubernetes, or Kafka. That's what you wired up in Lesson 03. Then parsers extract structure, turning a string like 203.0.10342, failed password, into a structured event with an IP, a user, and an event type. Scenarios watch those events through leaky buckets and emit decisions when a bucket overflows, and finally the LAPI stores those decisions and serves them to bouncers. That's Lesson 06. Today we live entirely in stages 2 and 3. Now zooming into stage 2, parsers themselves aren't monolithic. They run in 3 ordered substages, and you'll see these prefixes literally on disk under etc. CrowdSec parsers. First, S00 raw normalizes. It strips syslog wrappers, decodes JSON, stitches multi-line logs into one clean string. Then S01 parse does the real work, applying a Grok pattern to pull out named fields like source IP or username and populating EVT meta. If Grok fails here, the event is dropped. Finally, S02 enrich layers on context, GeoIP country, ASN lookup, timestamp parsing, reverse DNS. Same order, every time. So what does one of these parsers actually look like on disk? It's just YAML with 4 sections you'll memorize quickly. Filter decides when this parser even runs. Here, only on SSHD events. Grok pulls the user and source IP out of the message field using named captures. Statics writes those values back onto the event as metadata, and onSuccess tells CrowdSec to hand off to the next stage. Filter, Grok, statics, onSuccess, that's the whole anatomy. Now let's zoom in on that Grok line, because Grok is the single concept that makes parsers click. Think of it as regex with a vocabulary. Instead of handcrafting 4-digit nonsense for an IP, you write %brace IP brace and you're done. The syntax is small: bare pattern to match, :name to capture, :name :int to cast. And CrowdSec ships hundreds of these: IP, number, word, user, data, greedy data, HTTP date. One tip that will save you hours: paste your log line into grokdebugger.com before you ever touch a YAML file. So let's walk a real packet through the machine. A failed SSH login arrives in stage S00 raw. That timestamp, host name, SSHD brackets, the whole syslog line. In S01 parse, our pattern fires and Grok plucks out 3 things: the username admin, the source IP, and the port. Cast to an integer because we asked for :int. Those land in EVT parsed. Then a tiny statics block promotes source IP into EVT meta and stamps a log type of SSH failed auth. Remember the distinction: parsed is the raw catch, meta is the curated surface that scenarios actually filter on. Now those enriched events flow into scenarios, and every scenario is tuned with just 3 numbers. Capacity is the bucket size, how many events fit before it overflows. Leak speed is the drain rate, written as a go duration like 10 seconds or 1 minute. Lower means the bucket fills faster, higher forgives slow, spread out attempts. And black hole is the silence period after a bucket fires, so you don't spam decisions during an active attack. Put them together. Capacity 5, leak speed 10 seconds, and you've described a ban after roughly 5 failed events in 50 seconds. 3 knobs, 1 algorithm. So here's all of that wired into a real YAML file. The canonical SSH brute force scenario shipped with CrowdSec. Type Leaky tells the engine which algorithm to use. Filter picks only the events your parser tagged as SSSH failed auth back in stage 2, and then capacity, leak speed, and black hole are the 3 knobs we just discussed. The one line I want to burn into your memory is group B, evt meta.source aux ip. Forget that. And every attacker on the internet shares a single bucket, which means either nobody gets banned or everybody does. 1 bucket per source IP, always. Now let's see how those 3 knobs actually move in practice. Standard SSH BF is tight. 5 tries, 10 seconds apart, done. But SSH slow BF widens the window to 10 minutes because patient attackers drip 1 attempt at a time. The HTTP scanner case flips it. Capacity 20, leak every second, because crawlers genuinely hammer, and distributed SSH BF, capacity 100, leak over a minute. That one only makes sense at the CAPI level, where you're correlating across the whole community. The threat model dictates the numbers, and when leaky bucket is overkill, you've got 2 simpler types in reserve, counter and trigger. So how do you actually verify any of this is working? Meet cscli explain, your single most important debugging tool. Feed it a raw log line, and it walks you through every stage you just learned about. SR0 raw, SR1 parse, SR2 enrich, then the scenarios pouring into their buckets. You can literally watch program equals SSHD get extracted, then source ip, then country and ASN appear from GOIP, and finally see SSHBF at 1 of 5, telling you exactly when it'll overflow. Add verbose for field-level diffs. Run this every single time you write a parser or scenario. It's the difference between guessing and knowing. Take a breath. This was the hardest lesson in the course, and it's worth pausing to lock in the 6 ideas everything else builds on. The pipeline is 4 stages: acquisition, parsers, scenarios, lapi. Parsers themselves split into 3 substages. SO0 normalizes, SO1 groks, SO2 enriches. Grok is rejects with names. EVT parsed holds raw captures. EVT meta holds the curated field scenarios actually filter on. Scenarios are leaky buckets defined in YAML, and 3 knobs, capacity, leak speed, and black hole, control how aggressive they are. Every hub collection, every custom rule, every debug session you'll ever run loops back to these 6. And that's lesson 04 in the bag. You've mapped the pipeline end to end, you can read a Grok pattern without flinching, the leaky bucket math actually makes sense, and you know how to interrogate the parser with cscli explain. That's the detection brain online. In lesson 05, we take the gloves off. You'll write your own scenarios from a blank YAML file, work with filters, expressions, and distinct counters, and unit test them properly. See you there.